Hello and welcome back to another session of serde-yaml. It's Byron speaking, and in the previous session we have analyzed what's currently state of the art, what's there for escaping strings. And we have had a look at plenty of implementations, namely the Python implementation, which is something that I actually don't want to look at, and the YAML Rust implementation, which is based on the run from serialized JSON, which is something that could be a good basis, but that still seems to be incomplete for certain whitespace Unicode characters that are unprintable, as they would involve a new line or line break in the string. And this is not handled here, but we shall handle this. Then there is, oh, actually, I might have closed the wrong file. Oh yeah, I closed the wrong file because I just closed the JSON implementation. They're all named the same. That is lib-yaml JSON encoder. That's the one. So that's actually what I want to keep for now. The emitter.py is what I do not want. That's the YAML implementation. And there is lib-yaml as well, which kind of shows how to do it right in the YAML world. And apparently for single quoted scalars, there's also some special handling needed to get this right. But this might just be related to line breaks. Yeah. That's line break stuff. That's folding stuff. We will just look at that later, I suppose. And indentation. So they do all of this at the same time. And right now our code is set up to not do it at the same time, but we will get at that. So first, let's set up the infrastructure to be able to make the right calls. The flow style here is what's anything. It could be plain, single quoted, double quoted, but what we want to find out is if we have to quote the string. And this can happen in the key mode as well as the if we are a key string or if we are a value string, but we don't know that here, and also we can't make assumptions. But the cool thing is that we only will do any kind of encoding if we have a string. So all this stuff only happens for cases when it actually is required. Okay, so long story short, what I would like to do is I would like to have a system that allows me to generate an encoded string and then see basically if we encoded anything. And if we encoded anything, we will use that one instead of the original value, which is a reference to a string, which we obviously cannot change. But we shouldn't, to us this shouldn't matter, because we will provide a string slice here, which is either the changed, adjusted version, or it is the original version. And this is how this code is already set up, but now we just need some functionality to encode a string. And yeah, I guess this is the only place where this will ever happen, so we can do it like that. We can have two versions encode, and we can also think about how to handle the folding, because this is all width based, and under these circumstances it doesn't really matter what's the order, but I think we would do better if you would do it right away and then fold it. So the escaping should happen here. So here's the escaping. The escaping happens. Yeah, so we change the string twice, right? So the first time, here we want to fold, here we want to escape, and then we want to fold. And this is something that nobody does because it's kind of inefficient. This means you read the string twice, you handle the string twice, if the width is not 0, which is when we do not do any folding, right? But for now, I say, well, whatever helps us to separate these algorithms nicely. Everything else I consider an optimization that I currently just do not want to do. Everything that increases complexity is something we do not want. Let's keep it as simple as possible. It's difficult enough, I say, for me at least. because to do it right, doing this right is not simple. And this is something that seems to be obvious when you look at other implementations that rely on additional implementations, right? I've seen like 3 different ways of encoding stuff, or in JSON, in the JSON world, 2 different ways. No, wait, 3 different ways. And they're all totally different and handle different cases, I think, and are more or less complete. And that's really something we want to watch out for. Yeah, it's kind of interesting. I would also, now that I'm saying that probably these are not complete, I mean, the Python version might be. So JSON dump s. What if we just dump a string foo is just foo? Interesting. I didn't know it can do that. So what happens if we put a Unicode 0085? All right, it does. It encodes it. That works here. But I don't see that this kind of stuff works elsewhere, like in the current serd implementation, for instance. I don't see it from the code, at least. JSON. Oh, no, wait. No, JSON does it, right? Here in Python. This will give me a... Yeah, it just tells me it's a backslash. No, wait. Double. It kind of... Yeah, it doesn't make any difference if I put in a dict here. Key equals that. Probably not. Oh. Does this work? It does work. Does this work? It does work. So it does it correctly, it seems. And what happens on x85? I think it can't do it. Huh? No, that's not an escape for him. That is an escape for him. Look at that. Now it kind of works. Yeah, kinda. I wonder, am I reading this correctly? That's 4 of these guys. How does that look like if it's in a file? It's like, I would read it as backslash backslash. Even though a -u85, oops. See? Has 4 characters, has 4 bytes just because it's Unicode. And this is represented by, oh wait. Let's have a look at these bytes. No, wait. That's the actual string. That's not an encoding here. This is why it is what it is. What am I doing wrong? Yeah, that's 4 characters because that's in plain text here. Damn it! So, yeah, that's also the same thing. How are Unicode encodings working in Python? Python string Unicode escape. Tell me. Just need to know real quick. Yeah. Show me how you escape it. /x works, but what's the rest? UA /UA. It does need to be UA here. Okay, that seemed, no wait, it's still the same thing. It's still a string like that. So that totally didn't work. Or maybe it's not a Unicode string, huh? Ah. See, it wasn't, I'm at Python 2 here. Now we have it. Ah, damn it. Damn it, I hate Python. I mean, sure, I should have known, right? But on the other hand, damn it, you. So then we can just go back to standard mode. I didn't even know that JSON is valid without the enclosing. Yeah, so this is what I would expect. This is exactly that. Cool. That works. And if you go with 20 or something, oh look, it converts it. Or that's something it doesn't need to escape. 19, there's something it needs to escape. I see. 85, then we have 2028. Cool, that just comes out perfectly fine. 29, what's 30? Is this interesting? How come? Is this non-printable? How does it know that it's non-printable? Maybe it's in this particular range where non-printable characters happen to be. Okay. So that's the JSON encoder. Apparently that's something I do want. Because that just gets the basics right. I kind of digress because I want to put in the actual functionality, but I'm still trying to understand. Yeah, maybe I should just put in the code and try it. And then I will see if this will actually work as I expect or not. Because right now I think I don't see any kind of U encoding that is in the higher ranges. I don't see it here. It's not there. Even though it should be there. So here, so escape sub. Here we have this. That's how does this work? Here we do it. So if that doesn't work, then we check if it's below 10,000. How come, man? And surrogate pairs. Oh my god. So that's basically what we want to look at. And the surrogate pair stuff is something that is just not implemented. Surrogate pair. That's probably, what's a surrogate pair? Is it like least significant bit encoding stuff? Surrogate pair, it's nothing they mention here. Nope, why would they? Unicode, surrogate pair, tell me about it. The term surrogate pair refers to a means of encoding Unicode characters with high code points in the UTF-16 encoding scheme. Really? Does it need to be UTF-16? Oh yeah, I think it was mentioned here as well. Surrogate pair and UTF-16. Aha. How does that work? Note that in UTF-16, characters above FF are written as 4 bytes using a surrogate pair. Okay, that's kind of similar to what UTF-8 does, huh? Even though it's not a surrogate pair, but it's least significant bit encoding, kind of. Least, is this mentioned somewhere? Unicode, least significant bit. Unicode for dummies, just use UTF-8. Yeah. Least. You don't need a bomb, yeah. There's no storage penalty. Yeah, we know we like UTF-8 for that reason. Here, multi-byte encoding, that's how they call it. Variable width encoding, huh? Multi-octet encoding. Okay, so that is that. Multi-byte sequence. But this is something our encoder does for us. We don't care about this. So the surrogate pair thing. This is, I mean, basically this is what's interesting for us, huh? And how can it know that it needs a surrogate pair here? Damn it. But it uses a surrogate pair. Based on okay. But how does it know that it's a surrogate pair in that situation? 2 code points become 1 code point. This is that. Oh my god. This is oh no, that's part of the formatting here. No, just to see, this is that. So maybe this is faster, is why they do it. It's just part of the formatting. Oh, I get it. All right. In hex. So does it mean that if I have something like 9,999, it will always do it? And if I have 10,000 or 10,001, it will start with a surrogate pair? Oh, it's 0x 10,000, so how much is that? Okay, so it's 60. Wow. I call that some numbers. So why does it need a surrogate pair? Because can it be that JSON only supports 4 there? No, here we are already at 5, and this still works nicely. So it's about the height of the number. So 65, 536 still works. And now we should actually get into the surrogate pair range. 100,000? No. Whatever that means here. Well. So if it's a string and has no UTF-8 character, then it just does the standard decoding. Otherwise, it does what it does. And this is the stuff I don't get here. So this is called with matches, right? And these matches are what? As individual characters, it seems. Okay. And that's the character range here. Okay. Escape ASCII sub. Yeah. Still don't get it. Maybe I'm looking at the wrong thing. Maybe it's just this. Escape sub. So here we go. How does it work? So that's a character class of all these characters. And this is the fun part here. This is matching. And then if we match, we just do our escaping here. And it doesn't care about anything else. As if this would always work. I don't know. I simply do not know how this works. Damn it. So that's a bad thing, obviously. Okay, let's just start. 20 minutes in, and I'm still not smarter than I was before. So let's finally do it. So I think I would like to have a buffer here because I need one. At least some, yeah, I want a string. And I was also thinking about having a buffer for the whenever I format something. Let's try to find a solution that works for format as well as anything else. And this will require some additional research because I'm not so fond of the FMT package here. I know we could probably just have a look at the format macro with a little bit of luck. It calls format args. I think I did that before because format args is kind of compiler built in. Is it really compiler built in? It is. Wow. How does that work? See, how does it work? I don't know. It's compiler built in. Special. Probably like a plug-in kind of that's triggered by that. But in theory, you can do all the stuff that they do here just using the functionality provided here. And all I want is a custom buffer. So if you have a formatter, how does a formatter work? Here, how does this guy work? He needs some sort of buffer. So how do I create this one? Right, fill, align, width. How can I set it up? It seems, right now I wouldn't know how to set it up. There's no new. Some fields omitted, so private fields here. I couldn't set it up. Arguments. Safely precompiled version of a format string. This cannot be generated at runtime because it cannot safely be done so no constructors are given and the fields are private to prevent modification. That's fine. I can probably use them. And then the formatter, does he work with arguments at some point? Not directly, but I've seen something like it. Traits format function. Oh, yeah, exactly. The format function and the write function takes an output stream. A precompiled format. Yeah, so this is probably what I want to use here, huh? Precompiled arguments that are created somehow. And yeah, this is what I want. And then I need to be able to write into a string. So probably I want a vector. What does implement write here? Oh, a string. String implements write. Awesome. Nice. I didn't know that. So yeah, I can have a string buffer and just use it in these multiple roles. Right. Awesome. Oh, it implements FMT write. And the function I was staring at uses an FMT write. Oh, I was thinking, damn it, it deals with bytes usually. That's perfect. So yeah, all we need is a string buffer. Yay! Answer, question answered. Buff shall be a string, and we will pre-allocate that. Buff string with capacity. I hope that is existing. And I think we just go with 64. Should be enough in most cases. How much is 64? Now let's go with kind of lines of code like 128, which is not a line of code anywhere, but it's kind of the number I make up here to prevent unnecessary reallocation, right? So that shall be our buff. And now we can work with that. I would just go with a member and code scalar with a member function here, member method. That will deal with encode escape JSON. And And yeah, what's the interface like? I mean, I am fine with, you know, if in the moment we put any escape in, we have more characters than we have before. So we could just, yeah, we could, and the thing is it changes state, right? So we could make it so that it's actually not a mutt and it gets all the state that it requires. That's totally possible. Why not? Source shall be a string and DST is a buffer that we will just write to directly as a mutt string, right? And this is all, yeah, it's kind of, I mean, I think I want to make it explicit, the buffer handling, but if I would or not make it explicit, I could clear the buffer. How do I clear a string, by the way? Let's figure this out. Because I think this might actually not, maybe it is possible. It should be possible. Clear, awesome. That will not release memory, but it will put the string back to a length of 0. You know what? I think I want to return a read-only version of the buffer. But if I do that, if I want to use it again within the same context, then I might not be able to because I have a read-only borrow on that thing. And yeah, you basically need to know what it is. The question is, if this is conditional, if I return the one or the other, how does the borrow checker know which one it is? Probably tracks that, huh? But even the borrow checker doesn't know what the runtime decides. So I'm not sure how that will be working. Damn it. Yeah, so right now that's kind of clear even to the borrow checker. No, it's, well, if I return anything, it starts to be unclear what kind of lifetime we are dealing with. Maybe I just put a bool that says did replacement or something. But that's also, I think that's faster. Let's just document it. Returns true if the destination buffer DST contains at least one escaped character from src. So that could be that, right? And the default shall be false here for now. And then we would have to decide here what to do. And if we would do it differently, if we would just use the destination buffer internally, we wouldn't have to decide. You could just make the call and use it. But what if you want to reuse this buffer? Then I have to pass in source to read from, and that's where stuff will stop working then. Yeah, totally. I can't imagine how to deal with the borrow checker here, because it will definitely complain if we have a read-only version and a writable borrow of that variable at the same time. I think what will happen is that it checks out self. I think that's how it will deal with that. If we pass in, or if we return something that is tied to self, then it will basically, the borrow checker will mark the entire self as read-only or something. And maybe that is why that will then fail. And yeah, something like that. The reason why I'm asking this is, how do we deal with, damn it, I feel so, I'm like a monkey. I have no idea. And I'm just hitting keys on my keyboard until by accident something useful comes out of there. Well, it's not that bad, but let's say many questions. I would like to deal with that efficiently, and the idea was to just return slices here. So if I change something, yeah, so here we do, right, the idea was to do the folding here. And then in the destination, we might have our values, and then I think what's happening is that the folding has to happen in the same function. It has to happen here. Escape and fold JSON something. And the folding therefore should probably, yeah, in the moment we write it, we have to do the folding. It's just like that. Otherwise we get into trouble here with our buffer handling. So it's more, what we are going to implement is more or less like, here it is, like this code that kind of includes the folding portion. See, this is the duplication that happens. And we might do it similarly. So if it's a space, then all of a sudden we do stuff with it. I have no idea how the folding works, and I didn't really intend to do it. Yeah, I guess this is how it goes. Escape and or fold. This is what happens here. Okay. And then, of course, it sucks a bit to have two different ways of encoding things, unless we can deduplicate the code required for folding. Yeah. And if we fold it, and now, oh wait. The thing is, if we folded something, now, now the string length can change because we can fold it or we can escape stuff, and now we don't know anymore what it is. So in the moment we fold stuff, we do not need to change the flow style. If we do have to encode stuff, we need to change the flow style. So the Boolean says, okay, we escaped something. And please note that the string in DST may also be folded and thus increase in length. So, for instance, if I have key value fold, okay, that doesn't work. That is that. And I think the white space just eaten, right? Yeah, totally. And here we now have a new line. Yeah, and this is how that works. So the folding doesn't require us to change the flow style at all. But yeah, so we have to do it more like this, I think, because we need to fold. So let's call it escape and escape JSON and fold. This is how that would be called, because that's what we need to do. And I'm also already thinking about deduplicating the code here. And I must admit that I don't know. Except for using a macro or using a function. Maybe we just have a function for this. Yeah, a function should be just fine. Okay, so let's do this. Let's start with the bluntcopy. And of course, this is something we cannot do. And we don't need to do, because that's coming later. That writing comes later. The string slice is what we're interested in, which will be either our buffer or it will be the source. That's it, just for myself. So we start here, then we do what we do. This is just the kind of aftercare that we need to do after this kind of loop. So the cool thing is, yeah, So we have no writer. That's one of the cool things. Let mutt escaped char is false, and we shall return escaped char. And whenever something happens, basically whenever we realize that we have to, where we continue, yeah, the escape portion could just be empty. Right? Where? Ah, I see. So this only gets called if we have at least one time hit the escaped path here. And this is where this happens. So basically here we say that we escaped a character. And here we do the same. Voila. And that's just it. So that's basically our escape handling. And that should already do something useful for us. But we will, of course, have a test for this very soon. But first we need to put it in, right? Does this work? No, wait. Sorry, it can't work because we have to deal with the destination thing. This is a string. We actually have write string here because that's part of the FMT interface. I think that's what they use as well for good reason. Right? Ah, very nice. So we can use that. We just say, well, look at that, DST, write string, DST, nice. And here the same thing, DST write string. V, the value V is something we don't have, that's source for us. Oh. Source, we iterate over bytes, yeah. I kind of like this style more. I don't know if that is idiomatic or not, but that way you have a nice block here, and I like this blockiness. Even though that is not bad at all, but I kind of prefer this one. I don't know. I kind of prefer this one still. Okay, let's do that. So that's V, that's source, sorry. Then destination right, yeah. Destination right, source start. And that is that. Cool. So now we should have something that has the potential of working. And of course, we don't need a mutable self anymore as we receive the destination right now. And I would like to make this explicit. I don't want to just under the covers change this thing. Oh, and that might not even work because this will require an immutable borrow where this is a mutable part of self, right? So I guess this will not work if this is not mutable, possibly. I will see. I'm uncertain about this. Let's see if that compiles without using it. We are 39 minutes in, long enough. I take my time, I must say. I'm not fast right now. Not at all. 75. Syntax error. Fair enough. That's our buff. Panic 366. True. Kind of two panics in a row. Here we want to very soon call our JSON thing. Unresolved name 321 because source lang. All right. And what now? Ugh. Does not implement any method. All right. We need to get it to bring it in. Let's bring it in. Self and right. No, wait. I think I want to bring it in here, just local. Use std. Can I do this? Use fmt right? Does this work? No. Okay, makes sense. So now we should have the right thing, but we don't have the correct return value, so we can't use this. Sure, makes sense, but at least it doesn't complain about our type anymore. Look at that. Where is this happening? Oh, damn it. 313. Okay, that's happening here. And we've got it in 360. This is something I could probably look at. Now that this panic isn't there anymore, this doesn't work, because now we have to take care of the return value. For now, I'll just do it like this. So one of these things should go away, and all that's left is these try statements here that don't match up anymore. The great thing is that this calls, I think, into, right? Try calls into on the error. So we are actually able to have a conversion trait from it does. Makes sense. But I think that's also consuming the from trait. Anyway, we could also just abort here. It's just 2 spots, 3 spots. Well, wait a moment. I think what I want is a custom return value, because I do not want to. Yeah, what can go wrong? The formatting can go wrong here, right? Is it expected to go wrong? Not really. You know what? Maybe I just unwrap it. Because what can go wrong here? Excuse me. It's not supposed to go wrong. And let's just do it like that. I'm saying this is a buffer. You just write stuff. Rust will crash anyway. If it can't allocate memory. And I just say, well, guess what? You can write one string into another always. No need to worry. This is what I express with my unwrap here. Boom. So that will now work better, and I think it will even compile. Awesome. And yeah, now we can use it. The folding we still have to do. And there's lots of stuff. Let's just call this infrastructure and call it a session in a moment. So now let's, yeah, we have a string, and we just want to see what's happening. If, or how this will work, if it works at all. So we provide the value here. Where is it? Chars as ref. That will be a string slice, and then we say mutt self buff. And I think I also want to clear the buffer. Let's do this in here just to be sure. DST clear. Good. And so if have escaped characters, if we have that, then we need to change our flow style. Oh, wait a moment. I think I'm not doing it correctly. Damn it. If it, yeah, not at all, because we need to escape this thing as well. So it's the same thing, but this will also do folding, even though if the width is 0, we will never do any folding. Yeah, so let's provide it with the width, because that's the only thing that influences our folding. Fold width, max fold width, let's call it like that. And that's hue size, huh? Probably so. Yeah, no wait. Yeah, I think it's a hue size. It's part of, it's the first element of a tuple struct. Here it is, it's a hue size. Max fold width, all right. So there we go, and I guess we have to just do it here. I have to pass on the, yeah, oh, and that's also depending on a match on our flow style. And we are only interested in whether or not we have a plain or double quoted one with JSON or not. So let's match on this. How do we do it? Yeah, so flow style is flow scalar style double quote, and then we have any kind of, yeah, let's have a ref of the escape strategy, escape format, like this. Changing a lot, but it's still okay. And now we can match on the escape format. Where's the width coming from? Ah, here it is coming from. And say we have escape format JSON. That's the first thing we will implement. Let's give it some space. And escape format YAML I will just put in right away. But say, well, listen, panic to do YAML escaping. Ah, come on, one space for me, thank you. So that will make this branch work nicely. Unfortunately, this I did escape something or not is something we will have to repeat then. But that's how it is. Let's try to get the call right, and we go further to the right all the time. This is a property I kind of can't get rid of in Rust. But then that's a bit annoying, because at some point, you know, you're just so far to the right that you have to ask yourself, is my design wrong? Can I fix this somehow? And of course, we want to put in the width here as a copy. So here we have escaped characters. Here we possibly have folded characters. And yeah, there's something we will just have to duplicate then for the YAML part, because it will work essentially the same. So if, where is it? The chars as ref lang is not equal to the self buff lang, then we have to return self buff. Otherwise, we can return chars as ref, and this will also be as ref, right? Because we want a string, and type inference should do its thing. If we get oh no, wait, the first branch here decides what kind of thing we get. So let's just say what we want, right? Let's just say we want a string slice, and then we don't have to be afraid that or that something won't work here because reasons. So this will just be fine now. And that's one way to get a slice, I guess. Then I wouldn't have to do it like that though. That should give us the slice that we seek so desperately. This will also give us the slice that we need. It's exhaustive. And we could even, if you look at this, we could even put it like that. So we kill one indentation level here. So if we have an escaped character, otherwise, if there is a change in length, and in a way, the escape character one, does it matter to us? No. Oh no, wait. If you have an escape character, actually, I don't care about the string slice here, do I? I do not. I do not care about the string slice. What I actually care about is the flow style. Huh. And that's another thing. In a let binding or in a destructured thing here, how do I specify types? Answer: I probably don't. Huh. So yeah, maybe we wanna do this. Oh, damn it. Now I'm having a syntactical issue here. And all I'm trying to do is get this basic thing to work. Oh, damn it. So that's also Rust, right? I'm still kind of slow, but also, yeah, I have to think hard to get the syntax right. Maybe I can live without type inference. Yeah, in a way, I probably just want this to be the return value, which at least means we can go up one level. Where is this? So that's the flow style. Go up. Fine. So now we need to return the right, every branch needs to return the right thing. So double quote. And then we have anything else. And if it's anything else, we just want to fold, right? And this is something I don't know how to implement yet because we don't have any folding code to do. Just fold. Just fold. It doesn't affect the flow style. And this is why we do this game here. We want to possibly change the flow style as we go. So here, return the original flow style as we do here, and Charles's ref as we do here. So it's actually this. And none of the branches we will return anything, so that's fine type-wise. This is also automatically the return statement. That's also fine. And yeah, here we have to do something. So if that's a fold, have escaped characters, possibly fold, have fold only. So if you have a fold only, we don't care about the style. We can just keep the style. Style unaffected, like this. But in this case, we want to enforce a certain style. And this is something, flow scalar style. Yeah, we can just have a static here somewhere. I don't know where it's best to put these. Maybe up here. Yeah, Yeah, I've seen this in the YAML Rust code. And until that point, I wasn't really sure how this can work. I think it was in the YAML. So it's static something here. This is how that works. Static, blah, blah, blah. And this is how you can actually assign simple values, give them the static lifetime, so you can return them by default as read-only something. That was my learning experience that I can put to a test now. Static, flow scalar style. Oh no, wait, static, blah, blah, blah. Static, what is it? It's flow double quote. And that shall be flow scalar style double quote. Thank you. And now I should be able to just enforce this here as a read-only thing. And that's that. Lifetime should be totally fine. It's static after all. And we are done. And this is how that works. So in the moment we have escape characters, we need double quotation here. And that's what this code is supposed to do. And YAML escaping is just something we have to implement, and the folding is also something we have to implement. So basically, we now go in 3 steps. First, we finalize the JSON escaping to be at the point where we think it's correct. Even though I don't know about the surrogate pair stuff, but you know, whatever. So if we have to do surrogate pair handling on encoder basis, then we can't have a crate that just does the encoding for us, because it wouldn't know, right? Unless it checks these characters again, which kind of would suck. Now I understand. I think I slowly understand now. The surrogate pair stuff. Yeah, I don't know. I will have to read up on this. We'll do so during lunch, I guess. So, yeah, and then we will take care of the folding code, which we will reuse in a few places, like here, and then in JSON, and then in YAML. And then finally we deal with the YAML escaping, and then we are done already. I mean, with the escaping stuff. There's lots of stuff still to be done, obviously. And yeah, it's going to be interesting how the folding code will work in a block context, but it could be relatively similar. We can make this work. All right, my dear borrow checker, what do you think about the stuff? This should work, even though we might not be able to. Yeah, I don't know. Let's see what it does. Probably hating us right now. Oh, true. The double quote wants to have a standard style. Yeah, look. In JSON, we want double quote JSON. So encoding escape format JSON. And then we want a double quote YAML, which is escape format. I hope that works. Does it? It's not a simple value anymore, but maybe simple enough? Probably not. Ha, good. So the constant is not his concern. And now we get into borrow checker trouble that I totally kind of expected, even though I couldn't express myself. So 372. Yeah. So this is, see, we borrow ourselves as mutable and then try to write the buffer, and that can't be done. So we just kick this one and adjust the signature a little. This is my first guess, my first stab at this. So we now use it internally, which should be fine. So that's self buff clear. That should still be fine because we borrow the entire self as mutable here, which is okay. We can do that. So now DST is self buff. Here again, self buff, and we are done. Now cannot borrow self. I I didn't know that. 371. Previous borrow occurs here. 338. Really? Oh, damn it. Why does it work? Why does it work here? Ah, because... Okay. So there we go. Yeah, I guess I need to put this into a separate method in order to have kind of fine-grained access. So let's undo this. Because right now... But look at this. Do I use self anywhere? No. And this kind of shows me a problem with my architecture. Because if I don't use self, then what do I want here with that? I don't want anything. So let's put it where encode, ASCII, whatnot happens to be. This is what we want. So that's actually, once again, a very nice trait of the borrow checker. People might think that the borrow checker hates them, and so they hate the borrow checker. But on the other hand, it just shows you directly what's, I mean, kind of indirectly what's wrong sometimes. So no self required. And this is the base requirement that we have. And I think I didn't undo this entirely. Okay, so now we can do it one more time. Can try it one more time. JSON and folds, no self required. Now we go with self. I have to wrap it again. Not self buff. Nice, and I think we will run into another borrow checker issue because we will now get an immutable buff reference, and then we try to write that thing using a mutable, but no, that's just a writer here that we take. I think this can work. This could work. Yay! Whatever that means. This could work. Unresolved name, destination. Did you mean source? No, I meant destination, which is indeed totally unresolved because I didn't undo everything. DST, mutt string. There we go. Might even work now. Woohoo! Awesome. Max folded width currently unused. True. I will leave that warning because he's totally right. I didn't implement this yet, but I prepared for it. Awesome. So here, this is our code. This is how that would work. And now I can basically add, well, let's run the test then. It should maybe panic at another level. Just fold, it doesn't affect the flow style. Ah, because escaping didn't do anything. No, wait. Oh, wait a moment. You know what? I think I want the escape format. This is what I want. And then I want to, in any case, because right now I only check this even. Yeah, I think the logic is still wrong. So give me some escape format, please. We could have default escape format like YAML, right? That's what we expect in all the non-JSON cases. This makes sense. Static YAML escape format. I can't spell escape. I always put an error in there, a typo. Escape format is an escape format. And then we just drop down YAML here. Exactly. And really the only thing we want here is to extract a borrow on the escape format. This is what we want. So, match escape format shall be so let's take everything out here because this must go elsewhere. So here, now we have the escape format and we return it. Or in this case, it will be the YAML escape format. Yeah, unfortunately, I have to, you know, if this was an option or something, I could unwrap it, but with the data structure as we have it here, we need to do it like that. Yeah. So here we get the escape format out of there. And now we can match on it. Fortunately, this moves us further to the left. ESC format. Why do I do this? I can do it like that, right? Sure I can. Return it, reassign it on a different level. Totally fine. And now I match on it. And if we are YAML, we will panic loudly. But in any remaining case, we will do the right thing. And this is what this is about. Oops. 300. I was quite bold to just try to test this, but maybe it actually works at some point. 301. No, what's your problem again? I don't get it right now. Let's try again. Let's do cargo build. I was planning to finish earlier, but it always happens that I kind of get stuck somewhere. 300 expected dot or open, found that. Oh, so first of all, I want to return a reference to this. Otherwise, an explicit escape format. So, what's the problem here? I still don't get it. Ah, it's a match. Oh man. Okay, cool. That even works. So now we should see a different kind of panic here to do YAML escaping C. We don't have that. And yeah, you know, I'm